All right, welcome to this video on the introduction of inequalities. What I would like you to do first is to write down all 6 of these inequalities on your paper. So pause the video now and do that, and then we'll start. All right, the first equation that you see here is x equals 7. So if I ask you to solve this equation, what would you put in for x to make this a true statement? Because solutions are what you put in for x to make the equation equal to something that's true. Well, actually, the only number you can put in here is 7, so you put a dot here on the number line to show that that's the only number on this number line you can put here for x that gives you a true statement. So x equals 7 can be written algebraically like this, or you can also write it as a number line, as a dot on a number line. Now, as you advance the type of equation into an inequality now, it still is the exact same thing. If I ask you what numbers can you put in for x to make a true statement here, you might be thinking 8, 9, 10, 11, all the way up to infinity. All those numbers work, and they're going to create a true statement. So then what we have is a boundary point. This number 7 is a boundary point, so you have 7, but 7 is not included as a possible true statement. 7 is not greater than 7. So we use open circles to show the boundary point of where it starts from, but not include that number. But then everything larger than 7 is off to the right, and that's what we get for our answer as a number line. And again, we can write algebraically our answers like this, or we can write our answers as a number line with an open circle at 7, saying that we're not including 7, but everything larger than that is the answer. Number 3, when you see this inequality, you're going to say I have a less than or equal to symbol here. That means x is less than or equal to negative 3. That means we're saying that negative 3 is a true statement. So if you put negative 3 in for x, it is equal to negative 3. So we're going to include negative 3 with a solid dot. And when it's included, you'll always see an equal sign underneath the inequality. Now if negative 3 works and everything's smaller than that, that means our arrow then goes off to the left. So our graph then looks like this. So things are going along pretty smooth so far. But now you get to number 4, and you're like, well, you can't just see the answer on number 4. So number 4, you actually have to solve it like an equation. So all these inequalities, don't let them psych you out. Just solve them like an equation first, and then we'll figure out the inequality part after. So let's just solve like an equation first. So 2x plus 3 equals 11. You've done stuff like this plenty of times. Subtract 3 to both sides, and then you get 2x equals 8. Divide by 2 to both sides, and then x equals 4. Well, I have my boundary point at 4. Since I have an equal sign, I'm going to make it a solid dot. The question is now, which way does my arrow go? Well, with equations and inequalities, this inequality can stay facing the same direction the whole way through also. So I could have solved this with the inequality like this as well. And then I'm looking at numbers that are less than or equal to 4. So that means that the numbers that are over here and off to the left. So my answer can look like a number line like this, or I can say it algebraically like this, and the answer is how you write those for ones like this that have a 2-step type inequality. Now, something special happens with number 5. When you solve number 5, watch what happens here. Solve it like an equation. I'll pretend like I have an equation right here first. If I have equal sign here, I would have negative 3x plus 4 equals 19. You can solve this. Subtract 4 to both sides, and then I've got negative 3x equals 15. Divide by negative 3 to both sides, and then I get x equals negative 5. Well, my boundary point here is at negative 5, but since I don't have an equal sign here, it's an open circle dot for that boundary point. The question is, which way should the arrow go? Now, like I said earlier, this inequality stays facing the same way the whole way through, and the only trick is with inequalities, if you ever divide by a negative or multiply by a negative in your solving process, this inequality has to turn around. So then eventually it goes like this. Now you might be wondering why. Let's just write out some numbers over here that are larger than negative 5, like this off to the right. 0 is included. Let's put a 0 in here. Does 0 make a true statement? Negative 3 times 0 makes 0, plus 4 is less than 19. So 4 is less than 19, that's true. So everything that's to the right of this, including the 0, creates true statements in this inequality. But again, remember, as you're going through this, if you ever divide by a negative right here, this inequality has to turn around the other direction. So our algebraic way of saying it is like this, and our number line answer way of doing it is like this. Hopefully you're not having too many questions so far. Now, this next question has you solving for x, and it's written backwards. Do you see how x is on the right-hand side? Well, when I add 4 to both sides here, like an equation, I would then have 7 is less than x. Now, this symbol means something completely different when you read it from left to right versus right to left. This symbol means a less than symbol when you read it from left to right. 7 is less than x, but if I read it from right to left, x is greater than 7. And all the numbers that are x values that are greater than 7 are off to the right. So you put a boundary point at 7 open circle, and the arrow then goes off to the right. So when you're reading these questions and you're trying to figure out which way the arrows should go, start by saying X, where the answer is, are the numbers that are greater than 7, those are off, always to the right. That's your number line answer. That's your algebraic answer. If you really wanted to, you could turn this around also and write it the way you're saying it. X is greater than 7. This answer also is a good answer to how you would solve that inequality. Now, flip your sheet over. On the back side, pause the video now and try to solve this inequality by solving like an equation first. X minus 14 is plus 7 equals 15. Pause the video now and try to solve this inequality and see then if you can get the two answers that you're supposed to get. All right.